Great. Okay, excellent. So today we're talking about private registries, and I am like a huge evangelist for private registries based on my experience as a Rust developer. I started coding in Rust in 2017, and I have worked in the trading realm quite a bit. And so there's been a lot of times where I've had private proprietary code that, I couldn't, it's not open source. I wasn't going to publish it to crates.io. And, in general, I think people know that Cargo and crates.io and docs.rs and how well everything works together is a really great story for code reuse for Rust. And, I've thought about, Rust as the most loved language, and you guys are here. You probably have a lot of your own reasons why Rust is your most loved language, why you like working in Rust. I personally, started off, I came to Rust for the speed and I stayed for the safety is kind of how I put it. Like I needed a program that ran faster. And then I was like amazed that my Rust programs didn't crash. But as I started building bigger and bigger Rust projects, I think you kind of run into some issues. It's just not the same seamless story when it comes to code reuse and using to crate dependencies that are internal private crates. There's some complications to it, and it's not quite the same thing. So today what we're going to do is we're going to like dive into all the kinds of ways that you can do code reuse using Cargo and your cargo.toml and all that configuration, culminating in private registries and kind of the spiel for why private registries. So I am the founder of Shipyard.rs, which is a private crate registry service, like a cloud service. The reason that I did that is because I'm such an evangelist for this idea. I think that this helps people. It's great, and it's like a big improvement in productivity to your lives. But so anyway, we're going to kind of go through path-based, Git-based, works flows, and then private registries, and then so. But the place that I want to start is Cargo and why it works well. So what is it about, like, compared to Python pip, compared to npm, compared to a lot of other things out there? There's a lot of different languages, and I've never had as good of an experience adding dependencies with the package manager and build tool than I have with Rust. So what is it about it that works well? Because that's the thing that we're after. And there's a few aspects of this, and you're probably familiar with some of them. Adding new code dependencies is easy. It's so easy. We worry about micro dependencies. And I think when you say it's easy how? Like easy, it's easy to download. Like it's effortless for the source code to get downloaded. It just works. The configuration format is really well designed. I like that it's in TOML. It's got the flexibility in the format, in the manifest format that you need, but there's smart defaults if you just are doing the simple version. And then huge part of this, in my mind, is that Cargo applies semantic versioning based dependency resolution when it's figuring out which crates to go fetch from crates.io. And this allows you to specify your dependencies with differing like ranges of flexibility. You can opt in to just patch updates, or minor updates, or even major updates with a asterisk, with a kind of a star version requirement. And this works really well, in part because the people that publish crates to crates.io tend to do a good job of respecting semantic versioning rules in terms of the versioning that they give to their crate version releases. And huge thing. So when I started coding, it was in Python primarily for years, and I was really deep in Python, tons of Python. And there's a lot of things that I am so happy I don't have to ever deal with again as a Rust dev from Python. And a lot of them had to do with dependencies and avoiding circular dependency problems, and the one true version issue where, if your dependency, if you're depending on this library and it also depends on one that you want to use as well, the versions need to be aligned. There's tons of things that come up with Python. with Cargo and Rust, you can, like, multiple versions of the same crate coexist very peacefully for the most part across a code base, even across editions, which is incredible. Like, everyone knows about Python 2 to 3, and Rust is like, whatever you can, do 2018, 2021, it's all good. They can run together, and you get your free documentation, free with Cargo Doc, and then you get that full history at docs.rs for all of the versions. So it's, some people are IDE people. I'm a Vim user, and I've got a browser window open all day long looking at Rust documentation at docs.rs and other places. You can build it for the crate you're working on easily with Cargo Doc. And I think my opinion is that the crates that are published to crates.io tend to be relatively higher quality than a lot of the open source libraries in other language ecosystems. Why is that? Is a complicated answer. Maybe that may be a controversial opinion, but that's kind of my gut take on the quality level of these different things. And that makes it nice, because compared to the maturity of Rust, I think the breadth and depth of the libraries available at crates.io is pretty impressive. So those are all like awesome things that you guys know from working with Rust and Cargo all the time. And then what I think is true is that, as awesome as that is for adding open source crates from crates.io, you end up often having a kind of tale of two cities when it comes to your private code. So imagine you have like a fairly large proprietary code base of some kind. Maybe it's like, business code that you're not going to release to the public because there's a competitive advantage. Maybe it's just your private project or whatever. But you don't get exactly the same kind of story for using that code, especially as it gets bigger. You break it apart into multiple crates, in part to get faster build times, but there's some complications. It doesn't work as well as it does for the open source crates, and there's a lot of different reasons for that. So let's walk through the different approaches, the different methods, the pros and cons, and how this generally goes. And it always all starts with path-based dependencies, like you're prototyping or whatever, and you've got some other code in this directory locally, and you just add the path-based dependency, which is great. I mean, it's nice that you can do that. It's really helpful. It does not scale past one developer and a little bit of time, but you might try to scale it past one developer and a little bit of time. And true confessions, in circa 2017, 2018, when I was kind of a newer Rust developer, I was working on a trading system, running my own trading bots, and I had my Rust binary was using 40 internal crates that were all path-based dependencies, and I had this insane just file build system that would go pull the repos and do all this stuff to make sure I didn't miss anything and check what was in all the local directories. But it's that is like very, very brittle and very fragile. And the core reason why is that a path-based dependency is just whatever happens to currently be in some local directory, with zero ability of Cargo to fetch the source code on its own without you putting it in that directory on your own. So that's just not a great setup, and it's not nearly as good as what you get when you're using the open source crates from crates.io. So if you're on a team and another developer was going to try to build your crate with path-based dependencies, they have to also set up their local directories in some way to mimic what you declare in the cargo.toml. That is just that kind of quickly, everyone realizes very quickly that's not workable, I think. And you kind of move on to the next step in our evolution, which is Git-based dependencies, which are, pretty common, in the wild. I mean, I've encountered a lot of contexts in the business side of things where Git-based dependencies are being used. And the big advantage that you get from pointing your dependency to a Git repo is that now Cargo can fetch the source code from the internet without you needing to provide some external way of downloading the source code into the path local directory that we did in our path-based dependencies. And that's a big improvement, obviously. But I think, the thing that you run into as you start to use this is master is not a version. And then when you git pull, or when you push code to the branch that you are pointing towards, you can break production, or you can break codes that are depending on that crate as pointing at the Git branch, just by the nature of how that works. And it's just not very precise. You don't have the same granularity, and it's really hard for you to have, like, let's say you have 3 crates, and one of them wants to depend on one version of the 3rd crate, and another wants to depend on the the new upgrade, like the new patch release or the new minor release. That's not really possible with Git-based dependencies unless you never run cargo update, or you're like extremely careful and you're using all the P flags. There's cargo update, there's like P for package, and there's precise long flag. Like you have to like be extremely careful. It's tenuous. You're on the wire doing cargo update. And what really happens in my experience is like you just don't run cargo update ever until you have to, absolutely. And then when you do, it's a big pain because you're way behind, and now you're pulling in a huge number of changes. And so like that to me is the thing that's really common, and also really, really inferior to the nice code reuse story you get with registries, with the crates.io ecosystem, and also with private registries. So, but you can improve on this with the Git-based dependencies. So the next step in our development, we're getting better. We got spears now, you might say, and maybe we point our Git dependency, instead of just master or main, we're maybe going to point it to a version branch, like version 0.7.x, and then we push patch release updates to that branch, and then you can cargo update, get those patch release updates. Or you could also point your Git dependency at like a specific tag or a specific ref. And then what happens with that is it's just pointing at a fixed point in the source code history for all time until you change that dependency declaration. So it will just never update. It will just stay the same forever. That's okay. It's nice and stable, but you also don't get the updates ever like you would normally with cargo update. So this is kind of the best version of the Git-based dependencies, is to at least kind of provide some versioning approximations with Git branching or Git tags or some mechanism. And this is like another improvement from what we were doing before. But I think when I've done this in the past, I ended up like being kind of annoyed at all the tedious work it took to maintain this immaculate, like, Git history, the parallel Git branches, pulling bug fixes down to a previous version. It kind of was like a lot of work. Like it was so much work. I'm like, is this more work than setting up a private registry? That was kind of the question that I had on my mind. And there's also like, you kind of run into these things where like Git was designed for a certain purpose to solve a certain problem, and you're using it to solve a different problem that is kind of pretty well solved in some ways by it, but there's like these edges to what you're doing that you run into from time to time that make it's just not as seamless as you would hope. And so that's like kind of the Git. That's the best version of the Git-based dependencies is using some kind of branching or something. It's still got a lot of pitfalls. The next kind of stage in evolution, I think this is pretty common these days. It's a newer technique wasn't around when I started developing Rust for the first time. If I remember right, workspaces are often used like workspace works where you have a top level cargo.toml, which is like the workspace cargo.toml. And then inside of your repo, you have a bunch of folders or directories that are each one crate. And then inside of those, you can kind of refer back up to the workspace level cargo.toml and actually like defer versioning of dependencies back up to that the workspace level cargo toml, and like the authors of the package, things like that. This is like this is the best thing short of a private registry in many cases, especially when the code is very very tied together. Like an example would be like SQLX crate has like subcrates inside the repo, SQLX macros, SQLX core, SQLX like whatever. It's all related. It's all like part of this bigger, the whole purpose of all these subcrates is really to be implementing the work of the primary public crate interface that we're going to be exporting out for people to use. And they're all extremely interrelated and tied together. So it kind of makes sense for them to be in a workspace. The reason you would even split a workspace into subcrates in the first place, by the way, is that the crate is the most granular code unit in terms of cargo's build parallelism. And so you will get faster build times if you split your code into smaller crate units. So as you get bigger and bigger, if you have a very large crate, you can get some really, really gnarly build times, and you will get big improvements if you can split that up into crates. So the simplest, fastest way to do that is in the same mono repo and using workspace. And there are certain situations where that might be even ideal. I see this a lot, and I see it sometimes taken to really extreme lengths. I saw the InfluxDB IOX is like a new Rust implementation of InfluxDB time series database, and they have 80 separate crates in one workspace. And that there's a lot of management. If you go into that repo and look at all the build scripts and all the work that has to be done for that to be usable at all, it's very involved. And like what I think happens a lot, this is kind of my gut instinct, my personal take is a lot of times we're all doing all this stuff to avoid the pain of setting up a private registry in the first place, because it seems like it's kind of involved and scary, and there's not that many good options out there for it. So for a long time, I didn't set up a private registry either. I was doing all this stuff. I was setting up a 40 crate path-based monstrosity, all to avoid the cost of setting up a private registry. And then I finally did, and that's what we're going to pick up now. But private registries is just like crates.io, except for you can have your code that's proprietary code that isn't publicly available. And that way you add dependencies just like you do to crates.io, but you specify the registry in the dependency declaration, and then Cargo knows, through your configuration to go fetch that crate from a separate registry. Instead of downloading it from crates.io, it downloads it from your own registry that you control, your server somewhere. So the things that are great about private registry, it's the same seamless code reuse story you get with Cargo and crates.io. And it's the only one that is as nice to use as that, in my experience. And one of the big parts about it's the only one of these things that really gives you the semantic versioning based dependency resolution that Cargo provides, because even in the case like in the workspace ones, because they're local directories, you can't have two local directories existing in the same build. It's just whatever happens to be in there at build time. So you can't have you can't depend on multiple versions of a crate across the code base like you can with registries. So there's some things that are subtle, like advantages that help make this really work together, and they kind of build on each other, and it's a really smooth experience. So what's involved in running a private registry? Like what does it mean? What does that mean to do? What do you have to set up? What's the infrastructure? There's two parts to a private, a Rust private registry server, at least kind of traditionally. And then lately they've got this some new ways of doing things that are simplifying it, making it better. But traditionally, you guys have all like done cargo check or whatever, and you have like it's doing a git pull to the crates.io metadata index, and it's kind of applying the diffs, so you're applying all the changes to your cache local copy, and it's taking forever. And now that recently improved with sparse registries. But what was happening with that process was it was pulling changes from a Git repo that holds the metadata about the crates that are available at crates.io, which there's like, I think 100,000 or so, either crates or crate versions. I can't remember what that count is from. I downloaded them all at one point just to kind of do some like analysis of what was there, and also to like do performance benchmarking with like a large number of crates. But so you've got this Git repo that's the crate index. It holds the metadata, and your registry server is kind of like responsible for updating that repo as part of publishing a new crate version. And then in addition to that, there's a registry server that responds to like HTTP API requests from Cargo, that which is where Cargo downloads the crate files from. The crate files are just like a tar GZ archive of the source code, basically. And so for a working private registry is the combination of the Git repo for the index and the registry server that's responding to the API requests, and then also maintaining the repo as the new versions are published. And once you've got this all configured, set up, it's very easy to use, but it's a little involved to get it set up in the first place. In particular, if you have private code, there's quite a lot of questions as it relates to authentication that we'll get into a little bit later. Okay, we already talked about advantages, and let's talk about some pain points. Like, so the need for the registry server to exist in the form of both the Git repo index and the server itself creates kind of like this discontinuity between those two resources, and race conditions and kind of possible edge cases. The most obvious snag you kind of hit is like that you have to provide authentication for both of these things. So like, let's say you have a CI server, a build server of some kind, and you're going to publish new crate versions there. Well, your CI server, not only do you have to give it an SSH key to access the metadata repo, but you also have to give it the credentials, the auth token to make the API request to the registry server. So there's like this double, like it's kind of redundancy in terms of the credentials process. And then it also creates like, if you were trying to create high availability version of this thing, because Git was kind of designed to be driven by a person, programmatically writing with Git to a repo, it really needs to be done like one at a time, and you have to be controlling over making sure that you don't write twice, because then you could get the need to merge, reconcile and merge. I mean, there's kind of just, it's a little bit thorny in terms of administering a server, in terms of the possible things that could go wrong. It's not like the end of the world or like you can't deal with it. It's more than just a normal API server. And then so Cargo and crates.io, they were completely designed around open source code. And like all those design decisions like ended up kind of making it not that great for private code for a long time. It's only recently that story has been improving, and like we have workarounds at Shipyard for dealing with this. For if you want to build on stable, and if you want to build on nightly, there's unstable things that are like the proper way to do it. And those are kind of coming into there's a lot of discussions right now with the cargo team. We're working with them as well to kind of get that stuff going. We'll get a little bit into that in a little bit, but and then other pain points. There's not that many good open source libraries. Some of them are low quality. The one that I would recommend if you're going to do open source is MeUse, which is written in Clojure and requires the JVM. So it's a memory hog, and it's not easy to modify if you're a Rust dev, but it's pretty bomber in terms of a server. You can really count on it. So it's very robust. But there's nothing open source that will build your docs for you and do a docs.rs on your behalf. And certainly not like with the I've seen devs try to take the docs.rs source code and use it for private. I mean, they ended up kind of hitting a bunch of snags. You just, having worked on a registry service that's designed for private code, there's a lot of ways where everything was really the way that it was planned and designed, and the semantics and the API payloads and things were just not designed for private code originally. And so that's kind of a pain if you're hoping to host private code. So that's where Shipyard comes in. Shipyard is a private crate registry service. You sign up and it will create a new registry for you. You can publish your crates to them, and it's all of the API endpoints, including crate downloads, are 100% authenticated. That's like mandatory. We don't even have the option to download without authentication, so you have to have a token all the time. We have really worked as hard as we can possibly do to make this as easy and simple as possible. So, this is like the screen. This is the Shipyard's code is hosted on a private registry at Shipyard.rs, obviously. And this is the screen when you log in. So it shows you the crates, your downloads, you've got like the history of what was published. You get the docs. The docs are built for you. We build them, sandboxed, because it's executing arbitrary code. That was the whole thing. And it would be for anyone who wants to replicate this as well, because, just you might have different credential situation in terms of where your build server is or things like that. This is the view of the docs. This is, user management, token management. Everything's kind of set up for you. We have a free tier if you want to check this out. It's like enough to be usable. I mean, we certainly have users that are just using the free tier and that's it. You can publish up to 5 crates, unlimited crate versions to users, 4 gigs of storage for free at Shipyard.rs. And we're kind of more geared towards companies for the paid plans right now, but we're working on like different mixes of that type of stuff. This recently, Faster Than Lime, who is like my favorite Rust blogger in the whole world, and I was so excited about this, did a big section of one of his long series articles on Shipyard. Faster Than Lime actually is a Shipyard user, has a registry at Shipyard and regularly uses it. And it's been really awesome to see that, just as like somebody who has long read his articles, to like have him interacting with this and writing about it was really incredible. So you can check that out as well. If you want to do open source, like I said, MeUse is what I would recommend. MeUse is a Clojure library that was written from a guy in France who's obviously quite smart. I've not had a lot of luck modifying the source code because it's a Lisp language. I don't have any background with Lisp, and it's not very easy to dive into compared to a lot of stuff. Even I consider myself kind of pretty good at doing that, but not in this case. It's JVM. It'll take quite a bit of RAM. Not like horrendous amount of RAM, but so like 500 megs or something in a container if you want to run it in container. But that's the open source one I would pick if you wanted to do this kind of on your own in a different way. And I've got some like tips for you, like things that hard-won wisdom that I would pass on if you're getting into this stuff, if you're kind of setting it up. And one is this get fetch with CLI cargo configuration setting. I call it the silver bullet of cargo configuration troubleshooting because it solves so many different problems. And what it comes down to is that cargo by default uses this library libgit2 to perform clones and pulls. And then that library is like way worse at dealing with different permissions setups compared to the Git binary that the Git that you run commands on all day in the terminal. And if you put git fetch with CLI true, then cargo will instead use whatever Git you have in the path to perform pulls and clones, and that works much better in a much wider variety of situations. Second big tip is there's a way to prevent accidentally publishing your private crate to crates.io, which could happen because like the cargo command, cargo publish, has a command line, it has a flag registry where you specify what the registry is. If you didn't specify that, then it could conceivably, if there was no crate by that name at crates.io, it could conceivably get published to crates.io if you had already been logged in to crates.io with a token and so on. If you add this publish key to the package section of your cargo.toml, you can specify which registries are permitted, that this crate is permitted to be published to, and that will save you the potential of accidentally publishing code that you didn't want to be publishing to crates.io. Okay, so coming attractions, I mentioned some of the authorization difficulties and the things that made it not as suited for private code, proprietary code. Those are getting better all the time, and there's a lot of work being done on it. And the situation is there's a feature called registry auth. It's an unstable cargo feature. What it does is that for all of the API requests that cargo makes to the registry, it sends the credentials. Previously, some of the API requests, it just wouldn't send credentials, so couldn't authenticate them in any way. We have like a hacky workaround that where we configure cargo to send the token via the user agent header, which is not ideal, but it's better than zero authentication. But if you, with registry auth, it will send the credentials with every request, and you can now do a fully authenticated private registry. Then in addition, they are working on public key tokens. Right now, a authorization token for a private registry has been just a plain text token, some long string that's a secret, and if it were leaked, then it would be usable by anyone. And what cargo is going to be moving towards is public-private key situation where you sign the request with your private key, you provide the public key, and then cargo can you provide the cargo or your registry the public key in advance, and then when it gets the request, it can verify that you have the private key because it checks the signature with the public key. That's just a better way to do things in general. You don't need to worry about the possibility of the credential that you send in the payload leaking because it's just a signature. It doesn't give you anything at all. The private key always stays on your machine. That's better. It's obviously better, and that's what cargo will move towards eventually, but that's still in progress. And one other new thing is auth token scopes at crates.io, which is cool, where sometimes people manage like multiple different crates on crates.io, and you want to generate a token like just for one of those because maybe it's like you got one team working on that and another team working on another one, and you don't want to give someone a token or give a build server a token that has credentials to both crates when you really are only working on one. And that's the kind of thing that you can specify now with these auth token scopes, like what exactly the token can do, just higher granularity permissions in terms of what the token is authorized to perform on your behalf. And what we're working on at Shipyard, we've got our rewrite it in Rust chapter is underway right now. And like I said, we set up a MeUse registry server for you when you create a new registry at Shipyard.rs. But what we are doing is writing a Rust library to our own Rust private crate library, which is benefiting from the experience of managing a private crate service. And therefore it is kind of coming along very, very nicely. We're really excited about it. Feature velocity is just going to kind of go extremely up from what it's been, when we eliminate the need to perform operations like through this extra layer of MeUse kind of over the API. So we're working on a bunch of stuff as part of that. A lot of it is like higher granularity permissions for your tokens or users, where you can have IP-based limits, or you can have short-term tokens for your CI server. We're working on providing on-premise installs if people want that. We're looking at usage-based pricing for something that's easier to get in than the current initial tier, which is Pro, and also giving people all the options on their Rust doc builds. Like, you can do as many targets as you want. You can do whatever Rust flag, whatever flags you want in terms of how that's built. We're going to give you all the options. It's your registry, it's for you. Yeah, and then universal type search is something I'm personally excited about. I want to use it. That's why, this is my idea, is so that I can use it as much as a feature for Shipyard, which is that, when you run cargo doc and you get the little web site with all the docs, and there's a search bar at the top, and it auto completes to any of the types in your crate that you built for, and also any of the dependencies that you have. I just want that search box for all of the crates in the registry across, anything, and also the dependencies, all of them, and also the standard library, so that I have one search box to rule them all that can autocomplete on any type, and I can pull up the docs right away. So that's the idea behind that, and hopefully that comes together in the next few months. So those are that's my spiel. I think that this is like a big improvement to the life of a developer, a Rust developer. And I thought that I was surprised at what a big difference it made when I switched over to it. That's how I became an evangelist. That's why I decided to start Shipyard in the first place. Hopefully you've enjoyed learning the ins and outs of this stuff in a very detailed way. I'm really anxious to hear kind of about your experiences as well, what you learned about the code reuse story when it comes to private code. It's a little bit different. There's quite a lot to it, and I'm always learning things from people and what they're doing out in the wild. So that's everything I've got for you guys tonight, and would love to chat about it further with you.